Hi Dragons, so this is part 2. So now we're going to talk about another thing you'll have to identify on a test. And you're going to do this today for your forum, okay? So for the forum, what I'm going to ask you to do is to find a study, anywhere, and then to identify whether it's statistically significant, socially significant, neither or both. And you're going to have to learn those things. So here is, I'm going to put this up too on the Moodle. Here is something you may recognize, the normal distribution, okay, or the bell curve, whatever they called it in stats. So here's a normal distribution and the way that things are distributed. The middle is the mean. Let's say this is IQ, so the average IQ score is 115. Over here on this end are the plus. These are the geniuses, in the population. Maybe the Tiffin University student. And these are the the ones that are below average, like, I don't know, Heidelberg or something. Sorry, that was really mean. But anyway, so these are the positives and the negative, okay? And people fall all over the place here. I like to think that it's like sweeping dirt under a rug. And the most scores are where, there's a big increase right here on the top of the curve, okay? So most people score someplace in the middle. So 1 to 2 standard deviations of the mean. And I'm going to show you this right here. 1 to 2 standard deviations from the mean. All of that is considered normal. So when you're looking at what's normal in terms of psychological assessment, depending on how they're assessing you, whether it's for a mental illness or whatever, if you score within 1 to 2 standard deviations of the mean, then you're normal. If you fall above or below that, that's when, you have to think about that. So when you look at statistically significant findings, okay, you're doing a statistical test. And basically you're comparing two groups, okay? Let's say you're comparing what you would call the normal individual, whatever that is, to another group of people who scored over here, okay? And that would be a statistically significant finding. So anything under 0.05, so that would be 0.05, 0.04, 0.03, those kinds of things. Okay, 0.05, 0.04, 0.03, all the way to 0.01, maybe you'll have 0.0001, or even 0.000. Those things mean that that is highly statistically significant. So anything under 0.05. Well, what does that mean conceptually? Let me give you an example that we'll all understand. Let's say you want to know what the best condom is to prevent pregnancy, okay? And this is the kind of things that they would do in a lab when they do research to see how their product works, okay? And every lab does this. I don't care what it is that the product is. It could be a birth control pill. It could be, airline safety. It could be anything, okay? What that means is that 95 out of 100 times, 0.05. So 100 would be 1.00. So 0.05 is, once it hits that, it's statistically significant. So you want a condom that works 0.001 or 99% of the time, correct? You don't want one that works like 0.04, 0.03. You want it to be highly statistically significant. You don't want it to work 95% of the time, because if you have sex 100 times, you're going to have 5 children on the average statistically. Okay, maybe it won't work out that way, but that's pretty darn close. Okay, and you say, okay, well, I want 0.01, so I'm going to have sex 100 times, and I don't want to be pregnant, 0.01, or 1,000 times, 0.001. I want to have sex 1,000 times and then only have 1 kid. Okay, so I'm just saying conceptually that's what that means, and it's true for every industry. So, for instance, if you have a medication, let's say you go to the COVID vaccine, and that you want to know what the research says. Well, that's what the research is doing. They're looking for side effects or negative effects that deviate from the mean. So they'll say, well, it works to I've seen this for the COVID test, like Moderna it's a 95% immunity, okay? So that means out of 100 times that you can get that you're exposed to COVID, 5 times you'll probably get it. So you want to have those vaccines and those things to be as close to, 1 out of 1,000, 1 out of 100,000, things like that. So when you take a medication, they'll give you go to the pharmacist and they give you all these side effects and everything, and they'll give you all the data that's been done on it, and you have to be able to interpret that. Unfortunately, a lot of people haven't had a class in research and don't know how to do that, or statistics. So also there's a compilation for drugs called the PDR, Physician's Death Reference, and that also has all the data. So you know what statistical significance is now, right? 0.05, 0.04, 0.03. If it's 0.1, or if it's 1, 0.00 or 2.43, anything over 0.05, that's not statistically significant. Okay, so there's no difference. And the null hypothesis, there's no difference, that would be supported. Okay, let's say we did that. Let's go back to the police study, and we're looking for differences between male and female, police chiefs. And you find that there's no significant difference. So let's go to, what does it mean? Okay, so finding out, is it statistically significant isn't the end of the conversation, because now you have to find out, well, what does it mean? Is it socially significant? And that is an instance where the null hypothesis is really important. Okay, so let's say you get a statistic and it came out to 4.0, which is not statistically significant because it's greater than 0.05. Okay, so that means in reality that in terms of effectiveness in policing by arrests and successful prosecution, there's no difference whether you have a male police chief or a female police chief. So you're just as safe if you have a male or a female police chief. So if there's discrimination in hiring and people are saying, oh, we need a male police chief, no, statistically the research does not bear that out. Okay, so that's when a finding that is not statistically significant is socially significant. When else could we do that? Oh, well, right now we're in a pandemic, and you can choose between, well, you can't choose, you get what they give you. Pfizer, Moderna, there's the Oxford medication, and Johnson & Johnson is on the cusp of getting their medication approved. So here you are, and you're sitting there thinking to yourself, I want the best one. Which one is the best one? So now you're talking about, we're going to do a study that compares effectiveness and prevention of COVID for all of these different types of vaccinations. And are they all the same? What you're hoping for is that there's no statistical difference between any of the vaccinations that would make them socially significant, meaning it doesn't matter which one I get, they're all just as good as each other. Okay? So there's an instance where there wouldn't be statistically significant differences, but in terms of, I don't know, saving the world, it's an important thing. It's important socially. So that's a good example for that. So your things are statistically significant, socially significant, neither socially or statistically significant, or both statistically and socially significant. So if you're looking at, let's say there's an example of eyelashes on giraffes, and you're going to compare giraffes in you're going to compare giraffes in Botswana and giraffes in South Africa. And you notice, oh my God, the giraffes in South Africa have statistically significantly more eyelashes than the ones in Botswana. What does that mean? Well, so then you have to say, well, does it matter that one type of giraffe, the giraffes that live in Botswana, have more eyelashes than the ones in South Africa? What you have to make sure in that study is, because giraffes don't know, hey, am I crossing the border? Do I need a passport? They don't know that. They just go from one country to the next. So you want to know if they are truly just staying in Botswana and just truly staying in South Africa. So you'd have to clear that little matter up first. But you'd have to look for, is there some reason for it? And if there is no reason for it, then it could be socially significant, but it's not statistically significant. I mean, it should be statistically significant, but not socially significant. That it matters that one has more eyelashes or another. I'm going to put one thing up on the forum for you. It's not going to be on the forum because you're going to find something. It's going to be on the class. Maybe I'll save it for an exam. Never mind. I think I'm going to save that for the exam because that's a cool study. So that's what you'll be doing on an exam, trying to tell if something is socially significant, statistically significant, neither or both. Okay. So the conclusion that you reach, the generalization, the what does it mean, how you interpret your data. That is called a generalization, and you're basically taking what you learned from your statistics and making a big conclusion out of it. Okay, so that's called a generalization, and you will be doing that on your research project. There are two other things that you have to be aware of, and that is called, those are mistakes. Everybody makes mistakes. You will make mistakes. I have made mistakes. And those two types of mistake, one is called an artifact, and the other is called a confound. An artifact is a little mistake. You know, you coded something wrong, or here's your data and you misinterpreted it, or you know, you designed your study and you forgot about, oh, I forgot to look to see if they're in Botswana or South Africa. That might be important. You know, it's a little mistake. You can still go on with your research. Your research is still good. It's not a problem. A confound is a serious mistake. It will render your research useless. Like, it's something that's so big, and the mistake that you made was something that you have to throw that whole study out and start from scratch. Okay. The reason I have you meet with me before you do your study is so that you don't have a confound that's so big that your research is useless. I mean, you're going to do research no matter what. If you have a big mistake, you have a big mistake. But we're going to try and make you do good research, not one that has to be thrown away. Okay, so that's what we're looking to avoid for your research. Okay, so just make sure you know the difference between artifacts and confounds. Some don't have them, some are hard to find. But what you'll have to do on an exam is I'm going to give you some research, and then you're going to have to pick out all those things, like I said, and you'll have to pick out whether there's an artifact or a confound, okay? And I'm not trying to trick you. I'm just trying to show you, you know, here's the research. Do you see any? Okay? So you have to form a problem, and that's what you're going to say. A theory is always a question. Is there a difference between X and Y? And then the hypothesis says there's no difference. X is greater and Y is less than, okay? So that's what you're going to have to do on the test. And you're going to have to find the theory. So the problem formation is you have an idea that you want to talk about, and then here's how we're going to study it. Here's how we're going to form our way to answering this question, okay? And so when you do your idea form, you're basically telling me your problem formation, like, here's what I'm interested in. And then you and I will work on how we're going to test it, analyze it, generate data, that sort of thing, okay? You do have to make an abstract, and an abstract is just a summary of what your paper's about, and it answers 4 questions. What are you interested in? What did you do? What did you find? And what does it mean? Okay, 4 questions. And those are corresponding to your paper. What are you interested in? That's your lit review. What did you do? That's your method section. What did you find? That's your results section. And what does it mean? That's your discussion section. So your abstract is basically a summary of those things that you did, okay? And you do have to form a testable hypothesis. What that means is that you have to be able to generate data. And that's another reason why you're meeting with me. You might have this idea and it's really vague. Most likely it's really long. I want to do this, and I want to do this, and I want to do this. I just got one from a grad online student, and I was looking at it thinking, oh my God, you could research this issue the rest of your life. We have to cut this down. And a lot of times students will come to me with this great, you know, they have all these questions. I want to find this out. I want to find this out. And I just sit there and go, okay, bro, we're going to look at this little slice of it, because otherwise it'll become unmanageable. So we'll work on that together. Don't worry. And I know you're going to do some very great and interesting research. And I can't wait to see what you guys come up with, because you guys are, my students are fantastic at this. And then you basically have to test a model, okay? So the model in the police experiment one, males and females police chief, is a model of, you know, discrimination and women's ability versus men's ability, bias, those kinds of things. So that's the model you're testing. So that's the introduction that we've just done. So we're done with introduction. Next time, Thursday, we'll start on ethics, okay? So I'll put a bunch of stuff up for you tonight, and there we go. I'll see you for Friday's class. I keep forgetting it's Friday. I keep saying Thursday. And we'll go from there on ethics. All right. So see you then. Do your stuff. Stay healthy. It's a great day to be a dragon.